This is a proof of concept of how to decouple the subscription authentication mechanism from the physical elements of the access network. For this purpose, we will use a UICC card integrated in this pen drive to store user credentials of his subscription. We will introduce the UICC card within the multi-radio BeFEMTO node in order to trigger the authentication procedure and therefore buy our services. First of all, with no UICC card inserted in the multi-radio BeFEMTO node, let's check that the user can access any service. As you can see, it pop-ups a message claiming to introduce a UICC card. Now, we introduce the UICC card within the multi-radio BeFEMTO node. Now the subscriber is authenticated. But when we try to browse in internet, he has no services contract, and then the system asks to contract to buy some services. Now we're going to see more in detail what happens here.
As already stated, because the subscription has no internet service contract, even though the user is authenticated, the user will not be able to browse any website. Any attempt will be redirected to the operator's captive portal in order to contract the service. User 55 is the subscription associated to this UICC card. Let's contract the internet service. Done. We have a 100 megabit per second internet service. Automatically, the access network is being configured to remove the filter which prevented non-authorized internet access. Let's contract the IPTV service. Now, let's visit the IPTV menu web page. Notice that the subscriber is recognized as user 55. Here are the TV channels and the video on demand services. These are the movies available to purchase. Let's buy a movie. Selecting a media renderer, we can start enjoying the film. IPTV delivery is multicast based until the access network, and then offered to the user by means of a UPnP server in a unicast connection. But now, what happens when another user introduces his UICC card within the multi-radio BeFEMTO node? The access network authenticates the new subscription. In this testbed, this new subscription is identified as user 111. Let's see which films did she buy in the IPTV menu web page. As we can see, user 111 subscription purchased different films in her household. But thanks to the service mobility, she's able to purchase a new film or even display one of her previously acquired. Leaning on T-Span release to NGN standards, The scope of this scenario is being the development of the mechanisms that enable the subscriber authentication and the dynamical configuration of the access network. For this project, we have modified the entities within the network attachment subsystem to perform the AIP ACA authentication, provision the user terminal, and manage subscription service profile. We have also modified the resource and admission control subsystem to apply different service policies according to service subscription and enforce these policies within the access network.
We have demonstrated how the backhaul dynamically authenticates the user subscription and configures on real-time the access network according to the services the user has already contracted or services he just purchased. What is more, this authentication mechanism allows the user to carry his services with himself, enjoying them also in a secondary household, meeting the paradigm of my home moves with me. Continuing with the demonstration, once the user subscription is authenticated, we are going to show a demo of the multi-radio femto node services.
Multi-radio node demonstration. This is a proof of concept of demonstration. This is a RFID detector with the tag attached to the mobile. We have also a Wi-Fi access point, a 3G femto node connected to the multi-radio node, and a set of sensors and actuators that are wirelessly connected to the multi-radio node by means of a radio interface that is called Zigbee. This is the coordinator of the Zigbee nodes in white. So our demo begins when the user arrives at home. It has a tag attached to the user equipment. So when the user arrives at home, the multi-radio node will be able to set the profile of the services of the user. In this case, for example, we are sending by means of a Bluetooth interface a welcome message to the user terminal. But also we could download all the photographs that are stored in the user equipment. Now we have taken a picture right now that will be sent to the multi-radio node by means of a Bluetooth radio interface, and the multi-radio node could send these pictures for a printing service, for example. In this case, what we are going to do is to send these pictures from the multi-radio node to a digital frame that it is behind, that one, by means also of a Bluetooth interface. So the way is from the user terminal to the multi-radio node by means of Bluetooth, and from the multi-radio node to the digital frame also by means of Bluetooth, we'll be sending the picture. Now the picture is being downloaded in the digital frame. So the next step in our demonstration is the capability to control from the multi-radio node all the domotic services for home automation that could be provided in the home. So we have an iPhone that is connected by means of a 3G interface to the femto node that is included in the multi-radio node. And from the multi-radio node, we will be controlling all the sensors and the actuators of the home by means of a Zigbee radio interface. We are opening a web server from the iPhone which is connected to the multi-radio node by means of this 3G radio interface. And we are going to select one of the actuators that is now going to open, and we will select this actuator in order to switch on a lamp. This is the list of the sensors of actuators. We are going to select the lamp, and we are going to switch it on. So the communication in this case has gone between the iPhone to the multi-radio node by means of 3G, and from the multi-radio node to this lamp by means of a CP radio interface. Also, for example, we could switch on an alarm in order to provide any service related with security we want. And finally, we are going to use also another iPhone. In this case, it will be connected to the multi-radio node by means of a Wi-Fi radio interface, and the multi-radio node will communicate with a small robot, also by means of Wi-Fi. So we will be controlling this robot from our telephone. We are going to control the movement of the robot, and also we will be receiving the images that are captured from the robot by means of a webcam in our iPhone. So in this case, the communication is from the telephone up to the multi-radio node, and from the multi-radio node to the robot, also by means of Wi-Fi. The images and also the control could be done not only locally, connecting to the multi-radio node, but also it could be done remotely in any location, and in this case, the control of the robot would be done locally by means of the multi-radio node. These are the images we are receiving from the robot. And we are controlling the movement of the robot just only by means of the gyroscopes that are included in the iPhone. So we have seen a set of communication interfaces that are being used for the provision of services.